Hey everyone, welcome back to the channel. Today we're diving into the world of science experiments that you should definitely not try at home. I'm talking about the kind of stuff that makes your eyebrows shoot up and your jaw hit the floor, but also the kind that could turn your kitchen into a scene from a Michael Bay movie if you're not super careful. Remember, safety first. These experiments are for educational purposes only. Think of this as a highlight reel of what not to do, presented by yours truly, so you can still get that "whoa, science is cool" feeling without any of the risk. All right, let's kick things off with a bang, or rather a foosh. You might have seen this one before. It's called elephant toothpaste, and it's basically a chemical reaction that creates a ton of foam, like an elephant-sized amount of toothpaste, hence the name. Now, the key ingredient here is hydrogen peroxide, but not the stuff you use to clean a cut. We're talking concentrated stuff, way stronger. And when you mix it with a catalyst like potassium iodide, things get wild. See, the potassium iodide makes the hydrogen peroxide break down super fast, like instantly. And when hydrogen peroxide breaks down, it releases oxygen gas. Now, normally oxygen gas just floats away, no big deal. But in this reaction, it's trapped by soap, which is also in the mix, and bam! You get a massive eruption of foamy goodness. It's like a science fair volcano, but on steroids. But here's the thing, and I can't stress this enough, this reaction is exothermic. That's science speak for gets really hot. We're talking hot enough to cause serious burns if you're not careful. Plus, that foam, it's not your average bubble bath. It can irritate your skin and eyes, and if you accidentally breathe it in, well, let's just say you'll be making friends with your local ER. So, yeah, leave this one to the pros, or at least watch it from a safe distance with some popcorn. Okay, if you thought elephant toothpaste was intense, buckle up because we're about to crank things up to 11. Let's talk about the thermite reaction. This bad boy involves mixing aluminum powder and iron oxide, which might sound boring, but trust me, it's anything but. When these two get together, they react violently, releasing a tremendous amount of heat. Like, seriously, we're talking thousands of degrees Fahrenheit, hot enough to melt metal. And guess what? That's not even the coolest part. The thermite reaction doesn't just produce heat, it also produces molten iron as a byproduct. That's right, actual liquid metal, like something out of a Terminator movie. It's pretty awesome to watch from a safe distance, but you can probably guess why this isn't something you want to try in your backyard. I mean, think about it. You've got molten metal, which can cause severe burns if it touches you, even a tiny splash. Plus, the reaction itself is incredibly bright and can damage your eyes if you're not wearing proper protection. And did I mention the fire hazard? Yeah, because all that heat has to go somewhere, and it usually ends up igniting anything flammable nearby. So, unless you're a trained professional with a fire extinguisher and a hazmat suit, just enjoy the thermite reaction from the safety of your screen. All right, let's cool things down a bit, literally, with some liquid nitrogen. This stuff is crazy cold, like negative 321 degrees Fahrenheit cold. That's colder than the coldest temperature ever recorded on Earth. And because it's so cold, it can do some pretty wild things. Like, you can instantly freeze almost anything you dip in it, from flowers to fruit to, well, pretty much anything. But here's the catch. Liquid nitrogen is so cold that it can cause severe frostbite in an instant. And I'm not talking about your fingers getting a little numb. I'm talking about serious tissue damage that can lead to amputation if you're not careful. So yeah, no touching. And it gets even crazier. When liquid nitrogen warms up, it turns back into a gas, and that gas expands rapidly, like really rapidly. We're talking hundreds of times its original volume. So if you trap liquid nitrogen in a sealed container, guess what happens? Boom! You get an explosion. And not just any explosion, a cryogenic explosion. It's like something out of a sci-fi movie, except it's real, and it can seriously ruin your day. So, unless you're a scientist with a lab and a whole bunch of safety gear, just admire the cool effects of liquid nitrogen from afar. All right, let's get back to some explosive chemistry, shall we? This time we're talking about sodium and water. Now, you might be thinking, water, that's harmless, and you'd be right, for the most part. But when you introduce sodium metal into the equation, things get a little more reactive. You see, sodium is a highly reactive metal, meaning it really wants to bond with other elements, and water just happens to be made up of hydrogen and oxygen, two elements that sodium finds irresistible. So when you drop a chunk of sodium into water, it's like unleashing a tiny, highly reactive monster. The sodium immediately starts ripping apart water molecules, stealing their oxygen atoms and releasing hydrogen gas as a byproduct. And here's where things get explosive. Hydrogen gas is highly flammable, and the heat generated by the reaction is more than enough to ignite it. So you end up with a fiery explosion, often accompanied by a satisfying pop sound. Now I know what you're thinking. That sounds kind of fun. And yeah, it does look cool in controlled demonstrations, but trust me, you don't want to mess with this reaction at home. The explosions can be unpredictable and surprisingly powerful, especially if you use a large chunk of sodium. Plus, the sodium hydroxide that's produced as a byproduct is highly corrosive and can cause serious burns. All right, for our final act of potentially dangerous science, let's talk about something that's captured the imaginations of kids and adults alike for generations. Rockets. There's something undeniably cool about building something that can launch itself into the air, defying gravity with a fiery roar. But as tempting as it might be to try your hand at building your own rocket at home, I'm here to tell you, don't. Rocket science is incredibly complex, and even seemingly simple rockets involve a lot of potential energy that, if not handled correctly, can have explosive consequences. We're talking about highly flammable fuels, powerful oxidizers, and intricate designs that need to withstand intense pressure and heat. One small mistake during the building or launching process can turn your backyard project into a disaster. I'm not saying this to discourage your inner scientist or engineer. If you're interested in rocketry, there are plenty of safe and educational ways to explore it. You can join a local rocketry club, build model rockets with pre-made kits, or even try your hand at designing virtual rockets using computer simulations. But when it comes to building and launching rockets with real-deal propellants, it's best to leave that to the professionals with the knowledge, experience, and safety protocols to do it responsibly. Thanks for watching. Remember, these experiments are fascinating, but should only be done by professionals in a controlled environment. We've seen some seriously cool reactions today, from foamy eruptions to molten metal madness. But it's important to remember that these experiments can be incredibly dangerous if not handled with extreme care and expertise. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more exciting content. We've got a ton of awesome videos coming up, and you won't want to miss a single one. Stay curious, stay safe, and see you next time.